Ladies and gentlemen, boys and girls, thank you all very much for coming. My name is Martin, and over the next 30 minutes or so, I shall walk you through the fundamentals of PubSub with Diffusion. This will be the first in a series of webinars, each tackling a fundamental feature that a developer will likely encounter in their development of a solution. I invite you to put your questions to me via the Q&A feature, and we shall answer them throughout the presentation. Please click the raise your hand button if you prefer to voice your question instead. I promised you a code-first approach to this subject, but before we get to the good stuff, let's take a moment to explore what we mean by PubSub. PubSub is the primary model of data distribution used by Diffusion, and central to that is the concept of a topic. Clients subscribe to a topic. When data is published to the topic, the Diffusion server pushes an update out to all of the subscribed client. Now, there is some finer detail I'm not going into here, but at the core of it, this is the publish-subscribe pattern, recognizable as one-to-many communication. Additional to PubSub, Diffusion also has the request-response messaging feature, and this addresses the needs for other communication patterns, such as one-to-one and many-to-one. When understanding what a topic is, you might usefully imagine them as variables in the cloud with the following fundamental properties. Most importantly, a topic has a path, which you can think of as a name. Paths are delimited by the / character. All other Unicode characters are allowed, so you can use paths that map to concrete things or be completely abstract as you need. Now, the / character implies structure, but the structure need not be consistent. In more concrete terms, this means that the topic ABC does not imply that topics A or AB exist. They might not, and that's independent of ABC. Now, also, topics have a type, which is either string, int64, double, binary, and most popularly, JSON. The type, unsurprisingly, governs the type of data that a topic can contain. Next, we have the time series topics, which hold a historic list of values. So when you need historic depth rather than a single value, time series is your go-to. They're best used in combination with a single topic type, for example, a time series of JSON or a time series of double. You could use them to model a financial instrument over time, or say the odds on a horse, or the location of a parcel in a logistics system. And most importantly, a topic has a value. Publishing clients update this, and subscribing clients are delivered this. They can be persisted across reboots, which is important in a high availability scenario. They have topic properties. Now, these are used to hold metadata for integration with other features of the product, such as topic lifespans, topic views, etc. You can have a lot of them. It's common to create and then update a topic tree of 5 to 6 million of them. And importantly, data security is important. The full security model means that you have control over exactly who gets to create, update, and subscribe to topics. Permission changes are immediate, and security can be specific down to the individual topic. So enough of the slides, let's get to the good stuff. Okay. So I promised you a code-first approach into this subject, and that's exactly what we're going to do. What I have here is a series of notebooks I put together using Observable HQ, and let's just dive straight into the first one. So here we go. What we're going to have a look at here in this example is a worked but very simple and clean example how you can publish data into Diffusion using, in this case, our JavaScript client, and then also subscribe to data using the same JavaScript client. I'm going to focus purely on on JavaScript in this example. It's worth taking a moment to point out that we have support for many other programming languages as well in the product. But I'm going to be using JavaScript here for two reasons. Firstly, you can do everything using the JavaScript client that you can in all of the others. And secondly, because every single implementation that I've seen so far involves a web component where data is most often consumed by your audience in a web page. And that involves the use of JavaScript. So we're going to keep things simple. We're going to use JavaScript both to produce and consume the data. Okay, so the first thing we're going to do is we're going to load the Diffusion library. Most cases, JavaScript developers working inside Node will use require, which is exactly what we're going to do here. The JavaScript client is actually written in TypeScript, so we have first-class support for TypeScript type bindings as well, which makes things nice for TypeScript developers such as ourselves. Once the library is loaded, we then we establish our line of communication with the server. The session takes care of negotiating the underlying connection and maintains reliable reconnection. In this case, we're also authenticating because we're going to be creating topics. We're going to be creating topics once we've established ourselves as my user with a sensible password. There are a lot of options available here, and if we want to, we can dive into the options object, which is what we are providing here. It allows us to fine-grained control over options such as security and the underlying transports, and how to cope with disconnections if you want to provide your own strategy. Once we have our session, we're then going to make use of it to wire up this slider to a value inside the Diffusion server. So this particular slider here is wired up to a value, which in turn, when that changes, will push that value, update the values directly into a Diffusion topic. So let's start with the first piece of code. We established the topic path or topic name, which in this case is my topic. The user that we've authenticated as has free reign to create topics underneath the topic prefix my. After that, we then use session.topicupdate.set. We give it the topic path, my topic. We give it some type information, which in this case is going to be a double. So that's a 64-bit floating point number. Published value, which is supplied by this slider here. And we also provide this piece of type information, which is if the topic does not exist, then this is how to create it as. So let's just do a little bit of that. We'll just change the slider a little bit. And we can see that what it's doing is that it is publishing the value, and then it is through this particular return, it's returning my topic has been set to, in this case, 70.3. So far, it's a little bit dry. Let's have a look to see what that actually does, because what we want to do then is actually subscribe to the data that we're publishing. And let's do that down here. Down here, we've got a nice little gauge. Let's put the code away so we can see both the controls at the same time. There we go. So as I change this, the gauge changes as well. Now, it's important to understand here that the wiring, if you like, is from that input slider to a topic in a Diffusion Cloud server somewhere in Dublin, and then all the way back to this laptop again. And as you can see, the latency is pretty good. Let's have a look a little bit at the code that drives the gauge. There we go. So this is driven by a value called subscribed value. Whenever subscribed value changes, it updates the chart. Let's see how subscribed value gets set. Here we are. This piece of code here actually subscribes to it. Similarly to before, we established the topic path. We use our session. So the same session, because the same session can be used both to publish and subscribe and do lots of other things simultaneously. And we build our stream, which in this case is for a double value. And we react to events on that stream, there are a few events that we can react to, but most importantly, this is the value event. When the value event is triggered, we get a few things, but most importantly, we get the new value, and we're grabbing new value and we're updating subscribed value with that as a consequence, so that when the value arrives at the Diffusion server, at the Diffusion client, which is what this web page is, we then update the value, which updates the user interface. Okay. So this is ideal for infrequent updates, this particular API. It does carry an amount of overhead, type information, and complete value updates. So every time the value changes, it publishes or sends a new update value to the server. And the server has to calculate the value delta to then transmit that to its audience, which in the case of a number is not too much effort, but in the case of larger value data, for example, JSON strings or JSON records or binary, is quite a bit of effort. So what we're going to see in the next notebook is we're going to use the UpdateStream API to efficiently replay a lot more data in there. Let's explore an API that you would more typically use if you're publishing a lot more data or where the update frequency is that much higher. So this notebook uses the UpdateStream API, and it efficiently replays 4.5 hours of real foreign currency exchange data, and it does that with the same frequency that it was recorded. And we'll see the maths it uses to do that. So what we have here is a nice little chart. It really sort of visualizes what it's actually doing. We can see the frequency of updates for individual currencies, and we can also see something akin to an FX trading board, where we can see the currency pairs on the left-hand side, the bid, the offer, high, low, and open. And as values go up and down, they flash green or red with a nice little piece of CSS animation going on there. Interestingly, notice that mostly bid and offer are what's changing. Occasionally high and low will change as well, especially what's going on with the Aussie dollar right now. So you can imagine why transmitting only the changes to a record are the key to efficient delivery of data. But let's go into that a little bit more a little later on. So first thing we have to do is, as before, we load the Diffusion library. It's about 110K of compressed JavaScript. It's a one-time cost because the browser is going to cache it. And it's more than paid for in the bandwidth by savings made by using the Diffusion protocol. Once we have our library, we establish our session as before. We authenticate using my user and the super secret password. This particular cell here, we're going to start pumping the data into the Diffusion server. Once we have our session, once we've got our connection to the big guy, we can then start relaying data to them. I'm not going to spend too long in this code, except to say what it does. I had a lot of fun making this as compact, clean, and idiomatic as possible. But importantly, what it does is it starts pumping records into Diffusion. Let's have a look at those quickly. This is a live demo. What could possibly go wrong? But in the interests of transparency, let's bring in the data. So this was recorded early this year. It's about 4.5 hours of live data. And you can see that in each individual line is a JSON record, and there's a structure evident throughout all of them. They got the same fields all the way through. They got the name of the currency, they got the timestamp, that's the milliseconds since the epoch, got the bid, the offer, high value, low value, and open. And we just simply replay that in the same frequency with which it was recorded, so we can actually get an idea of the volatility of accounts. Okay, let's move on. So except before we do, we can see the last thing this does is it'll read the line at a time. It will pause for the historically correct amount of time before it then publishes a record, and it publishes the record using process record. And this is where the real joy comes in. This is where the diffusion magic comes into play. publish record, like it says here, this function creates an update stream if none exists, and then uses the update stream to efficiently update the topic. So the first thing we were going to do is to get an update stream if there isn't one. Have we seen this particular currency pair before? If we haven't done, right, let's create one. And it's correct that this should be done lazily because the set of currency pairs, of course, is unknowable. They are volatile. They may change. We may start trading currencies we haven't seen before, and stop and drop currencies that we have. So this set can change. So let's dig into the code. We build our topic specification. So in this case, it's going to be a JSON topic, and it's going to be called myFX record name. So USD GBP, for example. Once we've decided on the topic path, we then add it and we wait for that to take place. We then create the update stream at a particular path with a particular type. We then validate it. What I should say is that the update streams, they are optimistic update streams. So if we want to be certain that it's ready to go, we can call the validate method. And then we then stow it in our library of update streams by its record name. So we know that we now have an update stream. What we can then do is put it to work. This line, single line, say set the new value, and that will publish the JSON record, the records that we saw in the text editor just recently, straight into the topic. We'll also then log it out, and we'll keep some stats as well. And the stats are what drive this bar chart up here, which is still going. Okay. So we have been publishing our data. Let's explore how we can then subscribe to the data and actually visualize that. And what I'm going to do is I'm just going to pull this, create myself a new browser and put this one to one side so that we can continue to publish this data, and the rest of the records will be live. Okay, let's see how we can subscribe to all of that data. Similarly to before, first thing we're going to do is going to load the library, and then we're going to establish our session. A little bit important here, we're not delivering any credentials because we're connecting our session. We don't need to provide any credentials, as all we're going to do is consume the data, and we don't need any elevated permissions in which to do that in this server. The permission model is completely customizable, so you can set it up however you like, but out of the box, it's pretty close, such that the anonymous principal can subscribe to data. Anyway, we have our session. Let's now subscribe to them and start displaying the data. And then we'll cover some of the things to be wary of along the way. So in this particular block of code, we are going to select all of the topics underneath myFX. This is a topic selector. There's a lot of potency to be used inside topic selectors, and they give you a tremendous flexibility. Previously, we've been subscribing to individual topics. In this particular example, we're subscribing to, you can read this as the topic prefix my/fx, anything underneath there. So any topic called myFX and anything that descends from that, or children, great-grandchildren, and to the umpteenth degree, that will subscribe to all of the topics. And that's an unknowable number of topics as well. We then establish our stream, our value stream to deserialize, to parse the data as it comes off the wire and deliver it to us. And we're going to wire ourselves up to the value as the value event as before, specifically grabbing the new value. And then we're going to put it into into a data model, which then in turn drives the user interface with and animates the user interface. And then we're going to, so the first part is internal wiring. The second part is external signals to the server to tell it, right, I'm ready. I want you now to start sending me this stuff. I want to send me everything underneath my effects. And then we'll print out this message here. The reason why there's we separate the internal and external wiring is because they really are separate. As users move through an application, the topics that they care about are likely also to change. So we establish and I like to think of the value stream as the internal wiring. We establish that separately to the signaling to the server. It's fairly important we set this up first, although this is asynchronous. But it's a good practice to establish your value stream before you then select or indeed deselect topics from the diffusion server. Okay, so once the data has arrived, we then want to display it, and that's done in this case through table.set. The inquisitive can look into the supporting notebooks to see how that's done. But in this case, we've just displayed it as a table, and you can see that the data is still updating. There we go. Had me worried there for a moment. And principally, the bid and the offer records columns are the ones that are really changing. That's where we're seeing the volatility. One thing that we should cover off here is that there is room for improvement here, because this user interface, it builds out its rows as currencies arrive. In this case, we only have 10, and so the cost isn't particularly high. But when you are running on limited hardware or limited bandwidth, which is actually a more reasonable concern, then it's important that you have to answer the question, as is often put to us, how do we know when all our topics have arrived? And it's a reasonable question to ask, but the answer is not straightforward, because the set of topics that match a selection can change and do change. So the answer of all the topics is unanswerable, but pragmatically, you still have to answer that question. So what we're going to explore in the next notebook is how you answer that question, so that you can build a reasonable solution when you're running on, say, for example, an embedded platform, running on a smartphone, you have limited bandwidth, or you're dealing in large data sets as well. So let's have a look at that next. No questions from the audience just yet. There might be a test at the end, so put your questions in now. So what we're going to do in this notebook is tackle the issue raised in the prior notebook, which is often phrased, like I said, as how do I know when I have all my topics, which is not easy to answer because it depends on the volatility of the topics that you're subscribing to, but this explores a reasonable and pragmatic solution to that. So first thing is, before we are going to load our diffusion library, and then we establish our session, and the session is not authenticated because all we're going to do is consume data. Then we establish our value streams as before, and we push them into table.set. Interestingly, however, the table in this case has been primed not to visualize, not to render itself until table.display is called. It will build out its data model, but only when table.display is called will it render itself and then update itself. Down here we call session.select, which is the signal to the server. And when session.select, when the promise it returns resolves, or in this case, as we're using await, returns, when that happens, that is a signal from the diffusion server that the initial set of diffusion topics which matched your selector have been displayed. Now, subsequent topics may be created They may be deleted, or you may have them revealed to you because of permission changes, because permission changes are immediate, or they may, vice versa, they may be hidden from you because of permission changes as well. In both cases, those events are delivered to you in the same way through the value stream, actually through different events delivered to the value stream. And there we go. There's our table. So in this case, we gave it an extra option, which is display false. It was don't render just yet until I call display. And the net outcome in this case is much the same. This is a great big machine. It's got 12 cores, but when you're running on limited hardware, that sort of optimization matters. It also means that the user interface is less volatile, looks more consistent, and will encourage more faith from the people who are using it. So topic selectors are dynamic, and as topics are created, and if a topic is created after the selection completes, then that information will still be delivered via the value stream. Let's just focus on the last paragraph here, which I think that sums out well. So a well-designed solution will make its first render efficiently, but also handle subsequent changes to the topic selection. So once a selection is completed, you still have to cope with the possibility that the data model you're rendering may substantially change. Let's explore that in a little bit more in the next notebook. Okay, so as before, we load our library. We then place our session, connect our session. This time we're going to authenticate because we're going to be adding and removing topics. So this lovely graph shows all the topics that are underneath the prefix my. Unbound nodes are rendered in gray, for example, right here, whereas topic nodes in the tree where there is a topic are rendered in black, and you can actually see their value rendered underneath them. We can actually change this topic. It's actually, we have this tree because we have subscribed to it. And in fact, we can see pulsing on the left-hand side because the values are changing. And those values are the FX values we saw in an earlier notebook. That demo is still running. We're still pushing that data into the topic tree. But we subscribe to that. Which means that, and we've rendered the tree, but as topics are added and removed, we still need to react to that. So let's do that here. So let's put in a topic. We'll give it some content. Hit return. There we go. So topics will still be delivered, and let's do that a few more times as well with a bit of lorem ipsum. There we go. Let's remove some of them as well. Let's use the power of a topic selector. Topics and get rid of them. There we go. So we're back to where we were. Let's dig into the code that actually drives this. There we go. This is the important stuff. This is the interesting stuff. So we have our session, and we're going to build our, we're going to add our stream for a JSON value, but whereas previously we were just reacting to new values, we are reacting to two additional events, subscribe and unsubscribe. And we use that to update our internal data model, which is then rendered on the further up in the notebook up in here. So as we're subscribed and unsubscribed to topics because they may be created, removed, or we may have a permission change, with then as a subscriber to that topic space, we are then told that through an event, and we can react to that. Okay, let's move on. So we've covered quite a lot here in this, but there is, this is really, you should now have a very rugged and thorough understanding of the fundamentals of PubSub with Diffusion. There's an awful lot of material we could dive into and stuff which I recommend the curious and the interested should dive into. We've really focused on JSON topics during this. What we haven't really done, we used a double topic as well, but there are many other topic types as well, all of which are likely to be useful in your own use case. Different topic types have different properties, different memory footprints, different serializations on the wire. So they all have, bring value to the table. The time series topic delivers tremendous value, and I recommend looking into that, especially if you're working in the financial space, or if you're trying to build a chat solution, or if you just want to see the value as it changes over time. Topic properties are tremendously useful, especially when we're dealing with a feature inside Diffusion called the automatic topic removal. If you're building a topic tree of 5 or 6 million topics, then what you then have is you have to answer the question is, when do I take them away? Do I just leave them there forever? And the answer to that is automatic topic removal. And that means that when a topic is created, you can tell the server, just create this topic, and I could get rid of it after 24 hours, or when nobody cares about it because they haven't subscribed to it for 5 minutes, or nobody's updated it for 5 minutes or 7 seconds, or some specific thing. And when those criteria are met, then remove this topic, or remove this topic and a bunch of other topics like the descendant topics underneath. So you can be very specific about how the tree should take care of itself. We have also got update constraints, which gem nicely with cooperative locking. So if you want to have 2 or more clients updating data, then you can start to use what are recognizable as CAS primitives. You can specify that a topic should be updated from value X to value Y, but only if it is currently value X. But if it's not value X, then you can react accordingly. But optimistically, it is value X and will progress directly to value Y. There is also a partial update. So in circumstances where you don't want to keep the complete value of a topic natively because it's too big, or because you don't have it, then partial update is going to be your friend. And that works hand in hand with JSON patch, which is an open standard, which also has CAS-like operations in them as well, which works perfectly for multiple updates, or updates arriving from multiple locations. We have got topic views, which is a dynamic way to map one part of a topic tree to another and transform the data prior to publication, not just from another part of the topic tree, could be from a remote server. And you have also the opportunity to create topic feeds which are delayed or throttled. So you have the chance to devalue your premium data to create data which is suitable for delivery to prospects. You have missing topic notifications as well. So the opposite of automatic topic removal, you have the chance to add topics when people start inquiring about them. People select a topic which isn't there. You can get notice from the server and react accordingly, and then create the topic. That gives you both the left and the right hand, where the automatic topic removal takes away missing topic notification, can give to the topic tree. We also have topic notifications, where you can essentially subscribe not to the topics, but to the structure of the topic tree as well. Other APIs like fetch as well can play to that very, very strongly. Cool. Okay, well, I think we've come to the end of the notebooks. I wonder if now is a good time to put out to our audience and see if we have any questions. Okay, I can't see any questions. So I guess this was all crystal clear and everybody understood what I was talking about. That's excellent news. Cool. Well, that is all I have to cover off today. So thank you all very much for coming, and keep on coding.